So this is the law of sines. Law of sines is used to find angles and sides of what are called oblique triangles. And all that means, all oblique means is that it's not a right triangle. So if it's not a right triangle, you just lost Pythagorean theorem. That won't work. You just lost opposite, adjacent, hypotenuse. There's not a hypotenuse if there's not a right angle. Do you see? All that just went out the window. All that's gone. Everything we did on that little half sheet, gone. Okay? That's why we have law of sines instead. All right, in order to use law of sines, you must have 3 pieces of information. And at least one of them has to be a side. If all you're given are all 3 angles, you can't do the rest of the problem. Or you have to have at least one side. Now, what I'm about to write here is sort of an overview of what the rest of this unit is going to be. We're not going to do all of it today. We're going to do like a little bit each class, but I'm going to give you the kind of like overview. Do you get what I'm saying? Okay. So you could have one side and 2 angles. So one side and 2 angles. And the patterns for that would be angle, angle, side, and angle, side, angle. So one side and 2 angles. This simply means the side is in between the 2 angles. And this means that the side is not in between the 2 angles. I think that might be the first time I ever said angle, side, angle, and people didn't groan. Did you groan internally? Is that what happened? It was like, oh, this thing. All right. Those are the patterns we're going to do today. But I'm going to show you the rest of them. Okay. You can have 2 sides and what's called the non-included angle. Non-included means it's not in between. So if you have 2 sides and an angle that's not in between them, that's side-side angle. That's the one that's the naughty word spelled backwards. People write it forwards on the test, and I always think that that's funny, but anyway, that one. You can have 2 sides and the included angle. So what would that pattern be if the angle is now what we call included? 2 sides and the angle's included. Yeah, good. Side, angle, side. So the angle's in between the 2 sides is what we're saying. Yeah, go ahead.
So you always thought that SSA didn't exist.
So in geometry, you were trying to prove that triangles were congruent. That's not what we're doing. We're not, you were doing 2 triangles at once and trying to prove they were congruent. We're only going to have 1 triangle at a time, and we're just finding all the missing stuff. So we get all the patterns. But that naughty word spelled backwards is the weird one. So it's still the one that has like issues with it. All right. And then the last one is that you could have all 3 sides. All 3 sides is okay. You just can't have all 3 angles. Again, if all you have are angles, how could you ever figure out how long any of the sides are? You can't. So like you have to be able to be given at least one of the sides. So these patterns are law of sines. These 2 patterns are law of cosines. And we are only going to do the first 2 today. So again, I gave you like an overview of all the rest of the things that you're going to learn. We're going to do like a couple each day. We're just going to do the first 2, these 2 today. Okay. All right, so here is your law of sines. You have to start out with a side across from an angle. If you don't have a side across from an angle, it won't work. So it's little a over sine of a. And remember, the lowercase are the sides, the uppercase are the angles. Equals little b over sine of b. And for good measure, that would equal little c over sine of c. But you're only gonna be able to set up one ratio at a time. Okay, or proportion, I guess we should say, one proportion at a time. One ratio equals another ratio. You're never gonna have all three of those together, but we just say that that's, all true. All right, you are gonna find the angles first and then the sides in order smallest to biggest. And remember, the smallest side goes across from the smallest angle, the medium one goes across from the medium one, the bigger one goes across from the bigger one, and you can use that to kind of check your work. It doesn't actually matter what order you do them in for the patterns we're going to do today, but there is a pattern later where it does matter, and you will get the wrong answer if you do it out of order. So I try to just coach everyone to do smallest to biggest from the very get-go, and then it's not an issue later on. Okay. Oh, and I just said this. I forgot I had it printed on it. The smallest side is, what did I just say? Good. Across from the smallest angle. And again, that's the way you can kind of check your work at the end. Like, did I get the small ones across from each other and the medium ones across from each other and the bigger ones across from each other? Now, you will not draw these to scale. Okay. They're not right triangles anymore. So I just draw every triangle to look like this. It really doesn't matter as long as it has three sides, to be honest with you. Just go choo, 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 okay? Now, again, it won't matter for the patterns we're gonna do today, but it is gonna matter a lot later on. So I try to coach everyone to learn this right from the start and just do it the same way every time and be consistent. You want to start with the bottom left. I don't care if it's called A, B, or C, that's just a letter of the alphabet, but you wanna start with the bottom left of the triangle. So do you see how the first angle we were given is A? I'm going to put A right here, and it is 26 degrees. Again, it doesn't matter that it's A. It could have been B or C, but just put the first one there. Then you go to the bottom right, and my next angle is B, and that's 50. And so that means C goes at the top, which is the one that we don't have. Okay? And then they go across from each other. So when they give us baby C, that has to go across from angle C. So that 12 goes right there. And we are missing baby A and baby B. So that's drawing your picture. You get a point for that, just drawing and labeling the thing. Then we're going to decide what pattern we have. And again, for today, we're only going to do these two, angle, angle, side, or angle, side, angle. So basically, is the side in between the two angles or not? What do you think? Is this side in between the two angles? Yeah, good. Do you see how it's angle, side, angle? So that's our pattern. Now off to the side, we're going to make our little scavenger hunt list of everything that we're missing. Angles first. What angle are we missing? Angle C. And then we're missing little a and little b, but you want to do them smallest to biggest. Which is the smaller of the two? Good. Why is A the smaller one? The angle is 26. For B, it's 50. So there's our list. We're going to find everything in that order. You don't even need to write anything down to find angle C. How can we do angle C just in our calculator? You don't even have to write any word. Yeah. 180 minus the other two. So here's how I type it. There's a few different ways you can do it. I do 180 minus 26 and then minus 50. That's how I type it. Some people like to add them together and then as a secondary step, subtract it. It doesn't matter as long as you get the right answer. I got 104. Is that confirmation? All right. So this is not to scale because 104 is obtuse. That would look like this. Do you get what I'm saying? Don't redraw the triangle. I don't care if it's to scale or not. All right. Now to do law of sines, you need a side across from an angle. We have only one side, 12, and it's across from, oh, we just found that one. It's 104. So you're going to put 12 over 104 equals, that's setting up your proportion. And then what's the next thing on our list? A. So it's going to be A over sine of 26. So that's the setup. I will explain to you how to type it, but watch me point to this. You're going to cross multiply and divide. So what you'll type is 12 sine 26 divided by 104. The only thing you really need to be careful about is parentheses, because when you hit the sign button, it's gonna start a parenthesis, so you have to end it. Maybe watch me do it first and then you can do it, okay? It's 12 sine 26. Do you see how it started a parenthesis? All right, so I'm gonna end it. And then divided by, oh my gosh, I wrote something wrong. I'm so sorry. What did I forget right here? Can't just be 104 degrees. It has to be sine of 104. I'm so sorry. I am so sorry. It's the law of sines. Probably need a sign in there, Miss Cole. All right, I'm sorry. 12 sine of 26 divided by sine of 104. And then close parenthesis. And then that is your answer. I can't believe I did that. That was awful. I'm sorry. I'm so sorry. All right, 5.421. And I love that you guys are typing it. What happens sometimes in this unit, because there's so much button pushing, is people just watch me button push it and then copy my answer. Typing it is a skill that you need. You need to practice that, because on the test, it's a lot of button push. Okay? Now, when you go to setup to find the last one, it starts the exact same way. 12 over sine 104. That it didn't change because we're still doing the same problem. So just copy that down. And then on the other side, what's the last thing on our list here? Little b, baby b. So it'll be b over sine of, what is across from b? 50. So when you go to type that one, cross, multiply, and divide. So you're going to type 12 sine of 50 divided by sine of 104. And you should get a number bigger than 5.421. Because if you find them smallest to biggest, this one should be bigger. And that's the way you can kind of check your work. So you get a number bigger than 5? All right, 9.473. You guys are my quiet class, so I don't usually hear a lot. So if I don't hear any complaint, you're gonna have to be vocal if you need me to come look at your calculator. Or you're in groups, help each other. Otherwise, I'm gonna assume it was all fine. We're just gonna try that a couple more times, okay? Draw a triangle. Ooh, it doesn't need to be to scale, just draw a triangle. All right, so bottom left, I'm gonna start with the first angle I've got, which is A, that's 110. And then bottom right, will I call that B or C? C is the next one we have. So B goes at the top. And then little a is 19. That's going to go right here. We don't have baby B or baby C. So then the pattern, and again, we're only doing these two today. So I'm telling you, it's going to be one of these two. You have two angles and a side. What do you think? Yeah, angle, angle, side. Do you see how the side is not in between them? And I usually get asked, Miss Cole, if I write SAA, is that fine too? Yeah, it's the same thing. Doesn't matter what order it goes in. All right, so let's make our little scavenger hunt list. Angles first. What angle are we missing? B. Cool. And then out of the other two, actually, I can't tell which one is the smaller one. So let's find B first. Can you type in your calculator and find B? It's 180 minus the other two. I didn't put my calculator up there, so we'll see if anyone brave wants to share. 45? All right. So out of the two that are left, C and B, which one's the smaller one? Yep, C is the smaller one, good, and then B. So you need a side across from an angle. So look at your triangle. Do we have a side across from an angle? I mean, we will, because otherwise you can't do the problem. But do you see how these are across from each other? All right, so it'll be 19 over sine of 110. And if you want to even just go ahead and write that twice, some people end up liking doing that because you have to do two more. You have to find C and B, and it's going to start the same both times. So you can just write it twice. All right, what will go on the other side for this one? We want to find little c. Good, c over sine of 25. And when you type that in, it's cross multiply and divide. So it'll be 19 sine 25 divided by sine of 110. At 8.545. Okay. Again, if I don't hear any complaining, I'm gonna assume it's fine. And then for this last one, we have to find little b. So it'll be b over sine of, what was angle b? We found that one, didn't we? 45. So how would I type that one? What would I put in for that one?
19 sine
Yeah, good. 19 sine 45.
divided by sine of
Good. And what you can actually do, I typed the whole thing over again. If you hit the up button and hit enter, it'll bring back what you had before, and you can just change the 25 to a 45 because it's the same problem. And oh my gosh, did I get a number bigger than 8? Yes, because if you're finding them smallest to biggest, like last one should be the biggest one. Can I get feedback from you? Like, is this going okay? Are you understanding what I'm saying? Like, anything? Okay, then here's what we'll do. I'm gonna hit pause on the recording. I'm gonna have you try number 3. If that all goes well and you all seem okay, we'll skip 4 and 5. Because you don't really need, I mean, you're gonna do a delta math on this too and practice a ton of them. And there's not much to it. So if you do 3 and you feel like you've got it, then we'll just skip 4 and 5. Go over, you guys can tell me how this went. All right, so you need a side across from an angle. When you look in here, it looks like we don't have one, but we just found C is 58. So how will you set up your proportion, the first side of it? Yep, good. 12 over sine of 58. And if you want to even just go ahead and write that twice, because you need it for A and you need it for B. So it will be A over sine of, bless you, 50. And then B over sine of 72. And so A should be smaller than B when I type these. Anyone want to share what they got for A before I hit enter on here? 39. Okay, good. Did anyone else get 10.83 something? Doesn't matter. Okay, thumbs up. I'll take it. And then this is bigger than 10. So 13.457. Okay. I'll write up the answers for 4 and 5. You can check them if you feel like it, but you're gonna do plenty more and that's not real necessary. All right, and then the last thing we're gonna look at is there's 2 triangle area formulas. Do you know what the area of a triangle is? 1/2. I just couldn't hear you, but yeah, it's 1/2 base times height. If you don't have the height and your triangle is like this, then this is your formula. Area equals, and I do write out the word area so that you don't confuse it with capital A, which is an angle. Okay. 1/2 AB sine of angle C. Now there's 2 other versions of that. I do not want you to view them as 3 totally separate pieces of information. They're all the same thing. It just depends on how you jumble the letters. So another version of that is 1/2 AC sine of B. Do you see what I did there? Like, look at it and let it sink in. I just shifted the letters around. What would the last version of it be? Good, you guys see it, B, C, sign A. The letters A, B, and C are just letters of the alphabet. That is arbitrary. Like it could be LMNOP, it doesn't matter, you know, so don't view those as different. They're all the same thing, right? Now there's another one, which is called Heron's formula, which is if you don't have an angle at all, if all you have are the sides. And this one's kind of cool. It sort of geeks me out that this works. I don't know how he figured this out, like had way more free time than me. So there's this value that he called S. If you do 1/2 of adding all the sides together, so 1/2 A plus B plus C, then your area is, and you're going to draw a gigantic square root. Underneath of there, it's S times S minus A, S minus B, S minus C. That looks awful, but every year it goes fine because you're going to just put it in the calculator. But isn't that crazy? How do you figure that out? If you add all the sides together and do 1/2 of it, and then put it into that square root, that'll give you the area of any triangle. Neat, guys. Cool. You disagree, but I'm right. Cool. Cool that works. Right. I know, well, Heron, this guy Heron, I don't know. We're gonna just do these two. We'll do one of each. So look at number 6. Do you see how there's an angle, 22 degrees? Y'all see that? So it's gonna be one of these three. Because we're given angle A, which version of that are we using? The first one, the second one, or the third one? Yeah, third. You see how it's A? We have A, right? So your area is gonna be 1/2 BC sine of A. So that'd be 1/2 times 10 times 12 sine of 22 degrees. And you will literally just slam that in your calculator, do 3 decimal points. Now listen though, I didn't put units on this, but if there were, like for example, feet, what are the units for an area? Is feet squared, so square feet. Or if it was meters, like square meters, whatever, okay? All right, so we got 1/2 times 10 times 12 sine of 22. Anyone want to share? Are you feeling brave? Did you compare with your group and all get the same thing? Good. That's awesome with the calculator, right? 22.476 units squared. That guy has a loud car. Now you know. He wanted everyone.
I can do that too. It's
Right.
something special. Like,
All right, do you see how this one doesn't have an angle? So we're gonna do that Heron's formula because all you have are the sides. So you get this magical S value. It's 1/2, and then you just add them all together, and you can just feel free to put that in the calculator. Add them all up, and then 1/2 of it. I heard you whisper it. That's what I got too. And then your area, you're going to draw a big old square root. And underneath of that, you're going to put that number, so 26.5. And I just usually put like blank ones. You're going to subtract each of the sides from that. So 26.5 minus 12 would be 14.5. What would the next one be? 26.5 minus 16. It'd be 10.5, good. And then 26.5 minus 25 be 1.5. And oh gosh, did you get the whole final answer already? Hold on, I'm not there yet. All right, so big old square root, and then underneath of it, you're gonna put all that. Don't make me say it again, just all of those numbers. And that'll give you the area of the triangle. That's crazy. That's so cool that that works. Neat. So if all you have are the sides, you don't even have any angles, you can still get the area of the triangle.